Welcome back to the Deep Dive. Today we are stepping into the machine shop, a place where time is measured in micrometers and, well, precision is everything.
It really is.
And we're tackling one of the most fundamental choices a machinist has to make right when they walk up to a CNC lathe.
Yep. Picking the right chuck, the work-holding device.
And if you get this wrong, you're looking at a scrapped part immediately, or just hours of wasted time.
It's the first domino, you're right. And our sources, they all emphasize this choice is rarely about, what you like to use.
Right.
It's dictated by the material, the shape, and really critically, the tolerance you need to hit. So we want to give you a quick shortcut to understanding that whole decision.
So our mission today is to unpack the mechanics, the applications, and the skill level needed for both the 3-jaw and the 4-jaw chuck. We want you to walk away from this knowing exactly why you choose one over the other.
And if we can give you the rule of thumb right now,
Yep.
the thing all the machinists we surveyed said, it's this. A 3-jaw chuck is for fast, repetitive clamping.
On round or hexagonal stock.
Exactly. But you choose the 4-jaw chuck for anything square, rectangular, or, irregularly shaped, or when you need that incredibly high concentricity that you can only get by adjusting it yourself.
Okay, let's unpack this. 3 jaws versus 4. It sounds like such a minor difference, but mechanically, it's a complete game changer. What's actually happening inside the chuck that dictates those totally separate uses?
Well, it all comes down to the mechanism inside the chuck body. The 3-jaw chuck is designed for one thing, speed. And it gets that speed from something called a scroll plate.
Okay, for someone who's completely new to this, what is a scroll plate?
Imagine a big flat disc inside the chuck with a perfect spiral groove cut into it, almost like the threads on a giant screw.
Okay.
When you put the key in and turn it, you're actually rotating that one single plate. And the bottoms of all 3 jaws, they're all engaged in that same spiral groove.
So, because they're all locked into the same physical track, turning the key forces all 3 jaws to move at the same time.
At the exact same time and at the same rate, they move toward the center together.
Which gives you automatic self-centering.
Exactly. Instant. You clamp the part and bam, it's centered with the spindle. That's the magic of it, and that's why it's the default choice for production runs.
But when we switch to the 4-jaw chuck, we throw that whole scroll plate idea out.
Completely out the window. The 4-jaw is a totally independent system, no shared groove. Instead, each of the 4 jaws is mounted on its very own individual screw.
That sounds like a massive headache if you're trying to be fast. If the 3-jaw moves everything together, why would anyone want to adjust 4 separate jaws one by one?
Because that independence, that's its greatest strength. That's why it exists. It gives you, for one, a much stronger, more stable clamping force.
Okay.
And it lets you hold those weird, irregular shapes that the 3-jaw would just, spit out. But critically, it also lets you compensate for wear and tear on the chuck itself.
Oh, that's fascinating. So you're saying over years of use, that self-centering on the 3-jaw might not be so centered anymore. It could start to wobble.
Precisely. If that scroll plate wears down even a tiny bit,
Right.
the automatic center isn't the true center anymore, and you're stuck with whatever runout that wear gives you.
But with the 4-jaw,
With the 4-jaw, because you're adjusting each one by hand, you can always dial in a true zero runout. Doesn't matter how old the chuck is. You, the operator, have total control.
right. So let's talk about where that 3-jaw speed really pays off. Say a shop gets a huge order. They need to machine, 1,000 identical steel pins. The 3-jaw is the only real choice there, isn't it?
It's the undeniable choice. It's just simple math. In a high-volume shop, every single second the spindle isn't turning, that's money lost.
Yeah.
With a 3-jaw, the operator unclamps the finished part, pops in the new stock, tightens it, and hits go. The whole thing takes, maybe 30 seconds?
And you multiply that 30 seconds by 1,000 parts, and suddenly you've saved days of labor compared to manually centering each one.
Absolutely. The machine downtime is almost nothing. And on top of that, it's a low-skill operation. You don't need your master machinist doing that repetitive work. It makes the whole line faster and cheaper.
And the sources mention the consistency, too.
Right.
A good quality 3-jaw can have a repeat accuracy of around 0.01 millimeters. That's fantastic for a big batch of parts.
It is excellent. But, and this is the important part, this is where the trade-off comes in, that 0.01 millimeter accuracy is often the best a standard 3-jaw can do.
So 0.01 millimeter is fine for those 1,000 pins. But what if the blueprint calls for a tighter tolerance, say 0.005 millimeters? Does that just completely kill the efficiency benefit?
Well, that raises the essential question you, as the learner, have to figure out. If the part needs that higher precision, a three-jaw is probably going to produce too much scrap.
Okay.
So you have to weigh the cost of that scrap, the wasted metal, the wasted machine time, against the cost of paying a machinist to manually center every single one of those 1,000 parts on a four-jaw to hit that 0.005 millimeter.
That's the core calculation. Speed versus scrap. It sounds like the moment the required precision gets too tight, you have to switch from a production mindset to a precision mindset.
You've got it. And that precision mindset almost always leads to the four-jaw chuck. And then there's the other problem. The moment your part isn't round or a perfect hexagon, the three-jaw just hits a brick wall.
Right, you physically can't clamp a square block in a three-jaw. You'd only be touching on two corners.
It would wobble and fly right out. The four-jaw's superpower is that it gives you 4 independent points of contact. That's what gives you the versatility and the superior clamping force to hold non-symmetrical workpieces.
So you can lock down a square block.
You can put 2 opposing jaws on 2 parallel faces of the block, then bring the other 2 in to secure it. The force is distributed, it's rock solid.
And this versatility goes beyond just holding weird shapes. It's also about hitting that highest level of concentricity. Let's define a term here. We keep talking about accuracy and eliminating runout. For someone listening, what is runout?
Runout is, simply put, the wobble. Even if a part looks centered when it's spinning, if you put a really precise measuring tool against it, you might see the surface moving in and out slightly.
Okay.
If that movement is 0.01 millimeter, that's your runout. And if your part tolerance is less than that, the part's scrap.
So the four-jaw is the ultimate tool for killing that wobble. How does it do it?
Because the jaws are independent. You place a dial indicator against the part, and you literally manually bump the workpiece toward the true center, one jaw at a time. It's a slow process, but you can get that runout down to almost 0.
A level of accuracy a self-centering chuck just can't guarantee.
Never. But what's really fascinating is where you use that control to be deliberately off-center.
Ah, yes. Eccentric turning.
This is where the four-jaw becomes truly indispensable. It's the only way to do deliberate off-center turning.
Can you give us a concrete example?
Sure. Think of a cam lobe in an engine. A cam's job is to turn rotation into up and down motion, right? It only works because its center of rotation is intentionally offset from its physical center. To machine that, you have to clamp the workpiece in the four-jaw and manually shift it so its geometric center is, several millimeters away from the spindle's actual center.
Something that's literally impossible with a three-jaw.
Impossible. You'd be fighting the machine's own centering mechanism. Or think of an offset journal on a crankshaft. Same principle. You have to locate that part in a very specific eccentric position to make the cut. Only a four-jaw can do that.
So we have the three-jaw as the fast, simple workhorse, and the four-jaw as the versatile, high-precision specialist. Let's shift to the human element now. How does this choice change things for the operator?
Well, the contrast here is, it's everything. The three-jaw, like we said, has a very low skill threshold. A brand new operator can learn to load parts in a minute. It's perfect for a high-volume shop.
And the four-jaw setup, the sources call it a craft. That sounds a lot more involved.
It is a craft. It's a completely different mindset. It requires patience. It's a slow, deliberate process that can take several minutes, maybe 10 minutes or more, for a tricky part.
And you have to use a dial indicator.
You must. You're physically measuring the runout, and since there are 4 independent screws, when you adjust jaw 1 to fix the wobble.
You've probably just thrown off jaw 3 a little bit.
That's the painful reality. It's an iterative game. I've heard machinists joke it's like tuning a 4-string guitar. You tune one string, and it pulls the others slightly out of tune until you finally find that perfect balance.
So the four-jaw demands a higher labor cost. You need a more skilled operator doing very tedious work, which adds a lot of downtime before you even make the first cut.
That is the trade-off, exactly. That setup time makes it totally impractical for batch production. But that manual control, that craft, is what gives you the superior accuracy and versatility for those complex, one-off, or eccentric jobs.
This has been a really illuminating deep dive. So just to recap the core distinction for you listening, the three-jaw chuck is for speed and efficiency on standard round parts. You're prioritizing low setup time and consistency.
And you use the four-jaw chuck when you need maximum precision versatility for irregular shapes, or when you have to do that eccentric turning. You're accepting that it takes more skill and more time to get it right.
And since knowledge is most valuable when you can apply it, this brings us back to that core insight and raises one final thought for you. When you're planning a big job, and the required accuracy is just outside what that fast three-jaw can guarantee. How do you calculate the true cost difference?
You have to weigh the cost of manual labor paying a skilled machinist to spend 10 minutes on every single part with the four-jaw against the cost of material, time, and reputation that you'd lose from the scrap rate of using the faster but less precise three-jaw. That decision is often what separates a good shop from a great one.